Hello students, welcome back to this channel. I'm Rinkesh sir, a mathematics teacher at Lux School of Science. Today we'll start with the miscellaneous exercise of chapter 3rd. Till now we had completed till exercise 3.4 of chapter 3rd matrices. Right? If you like my videos, then please subscribe this channel. Now let's start with the miscellaneous exercise with the first question. See, the first question says that A is a matrix given 0, 1, 0, 0. And we have to show that AI plus BA whole raised to n equals to a raised to n I plus n a raised to n minus 1 B A. Clear? Where I is the identity matrix of order 2, means 2 cross 2 square matrix I, and n belongs to n. Okay, so now this we will prove by using principle of mathematical induction. If you will recall that you are in chapter number 4, you had used this in standard 11. That was principle of mathematical induction. First, we are taking n equal to 1, means we are taking p of 1. Then we are assuming let p of k be true, and using that, we prove that p of k plus 1 is also true. So from this, according to first principle of mathematical induction, LHS equal to RHS. So we will be using that method. Okay, so this we have to prove it. Okay, for n equal to 1. So what is LHS? A I. I means 0100. Sorry, it's I. 1001. Right? Plus B A. What is A? 0100 whole raised to n. What is n? 1. So this will be equal to multiplied by A multiplied by b, 0 into b into 0, 0, b, 0, 0. Now add both the matrix, a plus 0, a, 0 plus b, 0 plus 0, a plus 0, a. Clear? Now what is RHS? RHS is a raised to n. N means 1 I, that is 1001 plus a n. N means 1, a raised to 1 minus 1 means a raised to 0, b, and what is a? That is 0, 1, 0, 0. So multiplied with a 0, 0, a plus 1 a raised to 0 1. So the only thing remaining is b into this matrix, 0 b 0 0. So this will be a b 0 a, and this is equal to LHS. See, so what does this shows? P of 1 is true. Okay, I will just mark it. P of 1 is true. Clear? So what was our next step? Let P of k be true. So what does this implies? A I plus B A raised to k equal to A raised to k I plus k A raised to k minus 1 B A. Let's name this as 1, this as 2. Clear? So we had assumed P of k is true, so we get this. Now, for P of k plus 1, what we need to prove? AI plus BA raised to K plus 1 equal to A raised to K plus 1 I plus K plus 1 A raised to K plus 1 minus 1 K B A. Okay, we need to prove this. Clear? So let's check LHS. AI plus BA whole raised to K plus 1. So now we can separate this power. How? AI plus BA whole raised to K into AI plus BA. Clear? So K and this power 1. We did not write it. So this we have just expanded. Now what is this? Here, sorry, here. From 2, what we will get? Instead of this, I can replace this. A raised to K I. K A raised to K minus 1 B A into AI plus BA. From where? From 2. Clear? So now let's take it down here. Let's multiply A raised to K into I into A raised to K into A means A raised to K plus 1. I into I, it will be I. Remember, identity matrix just play role like 1 in the numeric system, like 1 into 1, 1. So I into I, it will be I, identity matrix. Clear? Plus A raised to K into I plus BA. So A raised to K, BA, and this I. Okay, now multiply this one. K A raised to K minus 1 into AI BA means first let's write down K A raised to K minus 1 into A raised to K minus 1 plus 1. Clear? BAI plus K A raised to K minus 1 B into B square A into A square. So K A K minus 1 B square into A square. Okay, let's name this as 3. So LHS is equal to 3 because I need to find out A square. Clear? This is A. So let's find out A square first. So what is A square? 0, 1, 0, 1. 0, 1, 0, 1. So what I will get? First, take this row. 0 into 0, 0 plus 1 into 0, 0. 1 into 0, 0 plus, sorry, it's 0. My mistake. 1 into 0, 0 plus 0 into 1, 0. Now second row, 0, 0. Obviously, we will multiply it with 0. So this is a 0 matrix. So what does this imply? This is 0. So K A raised to K minus 1 B square A square will be equal to 0 because I am multiplying this whole with 0 matrix. The answer will be 0 matrix. So from 3 and let's name 4 and 4 LHS is equal to A raised to K plus 1 I plus A raised to K BAI and BAI. You can see here common, right? And also A raised to K into A raised to K common. Clear? So A raised to K BAI, if I take common, Then what I will get here 1 plus k. Now what is this? See, a raised to k plus 1 I, a raised to k plus 1 I, a raised to k be a raised to k be a I. I means if I will write it down or if not write it down, it will be same, or I can rearrange it a raised to k plus 1 I. I say it plays just role like 1 in the numeric. So a into I will be equal to a. 1 plus k I am writing here k plus 1 into a raised to k b a, and this is equal to RHS. So p of k plus 1 is also true. Clear? So let me note it down. P of k plus 1 is also true. Clear? So P of 1 is true, P of k is true implies P of k plus 1 k plus 1 is true. Therefore, according to first principle of writing in short, PMI, principle of mathematical induction, P of n is true for every n belonging to n. So this is equal to this. Here I'm repeating what I did. First I took n equal to 1 and proved p of 1 equal to 2. Then I took p of k equal to true, okay, and make this formula. Then for p of k plus 1 I need to prove this. I took LHS, solved it here, showed that A square is 0 matrix, and rearranging it I got this as LHS. So from this, according to first principle of mathematical induction, P of n is true for every n belonging to n. So this is true for every n belonging to n. Clear? So note down question number 1. The next is question number 2. In question number 2, a 3 cross 3 matrix is given matrix A like 1 1 1 1 1 1 1 1 1. And you have to prove that A raised to n is equal to again 3 cross 3 matrix where 3 raised to n plus 1 at each position where n belongs to n, means natural number. Now again we will use the same method of principle of mathematical induction. Okay, so let's take first for n equal to 1. So what is LHS? A raised to 1 means 1 1 1 1 1 1 1 1 1. Clear? RHS 3 raised to 1 minus 1, 3 raised to 1 minus 1, 3 raised to 1 minus 1. At every place, 3 raised to 1 minus 1. Now 1 minus 1 is 0. Any number whose power is 0, it will be equal to 1. So this is also 1, 1, 1. And this is equal to LHS. So this implies P of 1 is true. Okay. Let me mark it down. P of 1 is true. Okay. Now what is our second step? Let P of k be true. Name this as 1. So A raised to k will be equal to 3 raised to k minus 1. Okay, so this will be equal to 3 raised to k minus 1, 3 raised to k minus 1 at each and every place. Okay, now let's start what we have to prove. For P of k plus 1, we have to prove a raised to k plus 1. This is equal to 3 raised to k plus 1 minus 1 k. Okay, we have to prove this. So let's start with LHS. That is equal to a raised to k plus 1. So let's separate the power. This will be a raised to k into a. Clear? So now let's do what is a raised to k? Let's name this as 2. From 2, what is it? 3 raised to k minus 1 at each place in a 3 cross 3 matrix into A means this matrix. Now you have to multiply it. How did we get from 2? I got this instead of A raised to k. Now see, when I'm multiplying, take the first row, write down here 3 raised to k minus 1. Let me solve it separately first. 3 raised to k minus 1 into 1, 3 raised to k minus 1. 3 raised to k minus 1 into 1, 3 raised to k minus 1 into 1. So this is 3 times 3 raised to k minus 1. Clear? So instead of this, I can write down directly 3 into 3 raised to k minus 1. So now, see when I will take second row, then also it will be same. Third row, then also it will be same. Here also 1, 1, 1, 1, 1, 1, 1, 1, 1. So every time I will get the same number. So 3 into 3 raised to k minus 1. Clear? Okay. So now what I can do, 3 means power 1 and k minus 1. So 1 plus k minus 1, k. So this will be equal to 3 raised to k, 3 raised to k. And this is equal to RHS. So according to first principle of mathematical induction, P of n is true for every n belonging to n. Clear? So this sum also we have solved like the first one using principle of mathematical induction. Just note down question number 2. Next is question number 3. Question number third is also similar to first and second. Means this also we have to prove using mathematical induction, principle of mathematical induction. Matrix A, 2 cross 2 matrix is given, that is 3 minus 4, 1 and minus 1. And you have to prove A raised to n, that is equal to 1 plus 2n minus 4n n and 1 minus 2n, where n is any positive integer. Okay, so now let's start with first n equal to 1 for n equal to 1. Let's take LHS. It's a raised to 1. And what is a? 3 minus 4, 1 minus 1 raised to 1 means as it is. Second, RHS. It's 1 plus 2. 2n means 2 into 1 minus 4 into 1, 1, 1 minus 2 into 1. So this will be equal to 1 plus 2, 3. Minus 4 into 1, minus 4. 1 and 1 minus 2, minus 1. So this is equal to LHS. You can see here. So P of 1 is true. Okay. What is our next step? Let's take P of K as true. So let P of K be true. So what will be the effect? A raised to K. Okay, let's name this as 1. Let us mark here that P of 1 is true. Okay. Now A raised to K will be equal to 1 plus 2K minus 4K K 1 minus 2K. Clear? So this name it as 2. Now for P of K plus 1, we have to prove A raised to K plus 1 equal to 1 plus 2 into k plus 1, that is, if I take 2 into k plus 1, this will be 2k plus 2. So 1 plus 2k plus 2. So this will be equal to 1 plus 2, 3. So 3 plus 2k. Second, minus 4 into k plus 1 means minus 4k minus 4. And instead of that, k plus 1. 1 minus 2n means 1 minus 2k minus 2. So minus 1 minus 2k. Clear? We need to prove this. Clear? So let's take LHS. So LHS is equal to A raised to k plus 1. Clear? So let's separate the power. A raised to k into A. So this will be equal to what is A raised to k? 1 plus 2k minus 4k. K 1 minus 2k. Into what is A? 3 minus 4, 1 minus 1. Clear? Now let's multiply. So what I will do? I will take first row. 1 plus 2k and minus 4k. Clear? So let's multiply here in rough. 3 into 1 plus 2k. 3 plus 6k. 1 into minus 4k minus 4k. So 3 plus 6k minus 4k. 3 plus 2k. Clear? Now with first second column, 1 plus 2k into 4 minus 4 minus 8k minus 4k into minus 1 plus 4k. So it's minus 4 minus 8k plus 4k. So it will be minus 4 minus plus minus 4k. Clear? Now let's take the second row. Kn 1 minus 2k. So k into 3, 3k. 1 minus 2k into 1 plus 1 minus 2k. So 3k minus 2k, that is k plus 1. Okay. Now With second column, k into minus 4, minus 4k. 1 minus 2k into minus 1 into minus 1, minus into minus plus 2k. So this will be minus 4k minus 1 plus 2k. This will be equal to minus 1, 2k minus 4k minus 2k. Okay. So let's see what we got. Is it same? Yes. So this is equal to RHS. That means P of k plus 1 is also true. Let me mark it. So P of k is true. P of k plus 1 is true implies P of k plus 1 is true. Therefore, according to first principle of mathematical induction, P of n is true for every n belonging to n. Clear? I'm repeating what I did. I took n equal to 1, put the value in LHS and RHS. I got same. So P of 1 is true. I took P of k as true and I got this. For P of k plus 1, I need to prove this. So I took LHS, a raised to k plus 1 into a, separated the power. Okay, I got this from 2. Okay, so from 2, I just replaced the value of a raised to k as this. And then I multiplied both these matrix. Both are 2 cross 2 matrix. They can be multiplied. I got answer which is equal to RHS. So P of k plus 1 is true. So according to first principle of mathematical induction, P of n is true for every n belonging to n. Clear? So just note down question number 3. So now I am giving you one extra sum that you have to solve by yourself. This sum is based on the first three sum of the miscellaneous exercise that we solved today, right? Using principle of mathematical induction. See, matrix A is cos theta, sin theta minus sin theta, cos theta, right? And you have to prove that a raised to n is equal to cos n theta sin n theta minus sin n theta cos n theta. How you are going to solve it? Exactly similar to the first three questions that we solved today. Take n equal to 1, prove LHS equal to RHS. Replace the value of n as 1. Take P of k equal to true, find out the formula, and using that, prove that P of k plus 1 equal to true. Okay? So try this by yourself. First, note down this question. Okay, I hope you'll be able to solve this question. Okay, that's it for today. In our next video, we will continue with this same exercise from question number 4. Thank you.